Important things to consider while constructing a mushroom growing house. Looking at each part of the mushroom house in detail. A mushroom growing house is a system where every component must work in perfect harmony. A failure in one area can compromise the entire operation. Here is a detailed breakdown of the 10 critical qualities for the roof, walls, floor, windows/ventilation, and door. The roof, the first line of defense. The roof is your primary shield against the elements. Its failure is catastrophic, leading to ruined crops, rampant contamination, and structural damage. Absolute watertight integrity. This is non-negotiable. A single leak can drip onto substrate, introducing bacteria and causing a bloom of green mold. The roof must be 100% waterproof, with all seams and penetrations, for vents, etc., perfectly sealed and flashed. Superior light blocking. The roof must block all direct sunlight. UV light is harmful to mycelium, and direct sun creates hot spots that can cook your crop and abort mushroom growth. The ideal roof is opaque or uses a twin-wall material that diffuses any light. High insulation value. R-value, a well-insulated roof, is critical for energy efficiency and temperature stability. It prevents the sun from baking the house in summer and stops heat from escaping in winter, reducing the load on your heating and cooling systems. Moisture and rot resistance. The roof material must be impervious to the constant high humidity inside the house. Materials like twin-wall polycarbonate, galvanized steel, or PVC-coated materials are ideal. Untreated wood will quickly rot and become a source of contamination. Reflective exterior finish. A white or light-colored roof reflects a significant amount of solar radiation, dramatically reducing the internal temperature. This is a simple but incredibly effective way to combat heat gain, especially in sunny climates. Structural support for equipment. The roof must be strong enough to support any equipment mounted on it, such as exhaust fans, intake vents, and potentially even misting lines. It also needs to support its own weight, plus any additional load from rain or snow. Smooth, cleanable surface. The interior surface of the roof should be smooth and non-porous to prevent condensation from collecting dust and spores, which can then drip onto your crop. This makes sanitization between cycles much more effective. Proper sloping for runoff. Even a flat roof should have a slight pitch to ensure that any condensation or accidental water runoff flows towards the edges or a designated drainage point, preventing puddling. Durable and long-lasting material. The roof takes the most abuse from weather. Investing in a durable, UV-stable material ensures the structure will last for years without degrading, cracking, or leaking. Seamless integration with walls. The point where the roof meets the walls is a prime location for leaks and drafts. This junction must be meticulously designed with proper flashing and sealing to maintain the house's airtight and watertight envelope. The walls. The airtight envelope. The walls create the controlled environment. Their primary job is to be a perfect barrier, holding the ideal conditions in and the outside world out. Airtight construction. Walls must be as airtight as possible to prevent the escape of humid air and the infiltration of dry, unfiltered air. This is crucial for maintaining consistent humidity and for efficient fresh air exchange, FAE, control. High insulation value. Like the roof, well-insulated walls are key to maintaining a stable temperature with minimal energy input. This prevents the ambient outside temperature from constantly influencing your grow room. Smooth, non-porous surface. The interior walls must be smooth and non-porous, like FRP panels, sealed concrete, or smooth vinyl, to prevent mold and bacteria from gaining a foothold. Every crevice is a potential reservoir for contamination. Easy to sanitize. The wall material and any sealants used must be able to withstand regular cleaning with strong disinfectants, like bleach or peroxide, without degrading. Light-proof. The walls must block all external light. Light leaks can cause premature or uneven pinning, the formation of baby mushrooms. Any seams or junctions should be sealed to be light-tight. Structural rigidity. Walls must be sturdy enough to support shelving, equipment, and the pressure of hanging plastic sheeting, if used as an inner liner, without bowing or flexing. Moisture-resistant material. The wall framing and sheathing must be resistant to rot and moisture damage. Pressure-treated wood, metal studs, or PVC framing are superior to standard untreated lumber. Seamless junctions. The corners where walls meet each other and where they meet the floor and ceiling, curved, if possible. This eliminates the 90-degree angle where dirt and contaminants are hardest to clean. Color. Interior walls are best painted white or a light color. This makes it easier to spot any contamination, improves the efficiency of your grow lights by reflecting them, and creates a brighter, more pleasant working environment. Provision for penetrations. The wall design must account for any necessary penetrations, for electrical conduits, fan housings, etc., and include a plan for sealing them airtight. The floor. The sanitary foundation. The floor is arguably the most critical surface for sanitation. It is where water, debris, and contaminants collect. Seamless, non-porous surface. The floor must be a single, continuous, non-porous surface. Poured and sealed concrete is the gold standard. Grouted tiles can work if the grout is sealed, but cracks and grout lines are potential weak points. Integrated drainage system. A central floor drain is essential. It allows you to thoroughly wash and disinfect the entire space between cycles, removing all standing water and contaminants. Slope towards the drain. The floor must have a gentle but consistent slope, e.g., 1/4 inch per foot, towards the drain to ensure that all water and cleaning solution flows away efficiently, leaving no puddles. Coved base. The junction where the floor meets the wall should be coved with a curved, seamless transition. This eliminates the 90-degree corner where dirt, water, and contaminants are impossible to clean out. Waterproof and chemical resistant. The floor sealant must be completely waterproof and able to withstand regular exposure to water and strong disinfectants without breaking down. Durability. The floor must be able to withstand constant foot traffic, the weight of shelving and equipment, and the movement of heavy mushroom blocks or carts without cracking or pitting. Thermal mass. Optional but beneficial, a concrete floor provides thermal mass, helping to stabilize the internal temperature of the house, buffering it against rapid swings. Slip-resistant finish. While the surface must be smooth, it should also provide some traction when wet to ensure safety for the grower. Sealed at the perimeter. The edge of the floor, where it meets the foundation or the base of the walls, must be completely sealed to prevent pests and water from intruding from below or outside. Easy access. The floor should be uncluttered and allow for easy access to all areas for cleaning and maintenance. Windows/ventilation. The lungs of the house. This system is not for light. It is for the controlled exchange of air. It is the most dynamic and critical system for producing high-quality mushrooms. Paired intake and exhaust. Ventilation must be a two-way street. You need a dedicated, filtered intake vent low on one side of the house and a powerful exhaust fan high on the opposite side to create effective cross-ventilation. Intake air filtration. The intake vent must be fitted with a fine filter, like a HEPA or MERV-rated filter, to prevent pests, mold spores, and other contaminants from being sucked directly into your clean growing environment. Properly sized for air volume. The exhaust fan must be powerful enough to replace the entire volume of air in the house in 1 to 5 minutes. An undersized fan is a common cause of poor mushroom development. Light-proof vents. Both the intake and exhaust openings must be designed so that no light leaks through when they are closed. This can be achieved with baffles or light-tight louvers. Insect screening. In addition to the fine filter on the intake, a coarser screen should be used on both intake and exhaust to prevent insects from entering the system. Strategic placement. Intake should be low to bring in fresh, cool air. Exhaust should be high to expel the warmer, CO2-laden air that naturally rises. Placing them on opposite walls ensures the air travels across the entire crop. Dampers for manual control. The system should include dampers that allow you to manually adjust the airflow rate, providing fine-tuning beyond the automated system. Backdraft prevention. The exhaust fan should have flappers or a damper to prevent outside air or pests from entering when the fan is off. Easy access for maintenance. The fans and filters must be easily accessible for regular cleaning and replacement. A clogged filter or dirty fan blades will cripple the system. The door. The critical seal. The door is the weakest point in the house's envelope. It is used constantly and is a prime route for air leaks and pests. It must be engineered to be better than just a simple door. Airtight seal. The door must seal perfectly when closed. This requires high-quality weather stripping or a rubber gasket that compresses tightly around the entire perimeter. Robust threshold. The threshold at the bottom of the door is critical. It must create a complete seal with the bottom of the door and be tall enough to stop pests and water from being easily kicked or blown under. Insulated core. The door should be insulated with a solid core, foam-filled, to match the R value of the walls, preventing it from being a major source of heat loss or gain. Wide enough for access. The door should be at least 36 inches, 1 meter, wide to allow for easy movement of large mushroom blocks, carts, and equipment without bumping and damaging the crop. Self-closing mechanism. A hydraulic or spring-loaded closer ensures the door is never accidentally left open, which would rapidly destroy the controlled environment. It should close slowly but firmly to ensure a tight seal. Durable and moisture-resistant construction. The door material, e.g., fiberglass, metal-clad, must not warp, rot, or delaminate in a high-humidity environment. Smooth, cleanable surface. Like the walls, the door surface should be smooth and non-porous for easy sanitization. Secure locking mechanism. A good latch or lock is necessary to pull the door tightly into its seal and to keep it securely closed. Light-proof design. The door should have no windows. If a window is desired for observation, it must be double-paned and completely light-tight when its cover is closed. The door edges must seal out all light. Swing direction. The door should swing out. This prevents the grower from having to fight against the air pressure when the ventilation system is running and makes it easier to move large items in and out.
Mm. Mm. Muy bad. Ogwabalimi abakutwala nibwo obuno.